You ever hit the undo button when you're typing or the back button in your browser? Well, if you have, then you've actually used a stack. Today, we're going to pull back the curtain on this really simple but incredibly powerful tool that's kind of hiding in plain sight in the software you use every single day. Let's get into it. So before we even get to the official name, I want you to just lock this one phrase in your head. It starts like this. Last one in is the first one out. Just picture a stack of dinner plates, right? You put a clean plate on top, and when you need one, you take that same top plate off first. Or maybe a stack of books. The last book you piled on is the first one you're going to grab. That one single idea, that's the key to this whole thing. And that idea, that's what we call the LIFO rule. It stands for last in, first out. And this isn't just, a guideline. It is the single, unbreakable law of how a stack operates. Everything a stack does comes from this one rule. So what is a stack? Technically speaking, it's what's known as an abstract data type, or ADT. Now, don't let the fancy name scare you. It's kind of like a car's steering wheel. You don't need to know how the gears and axles work underneath. You just know that when you turn the wheel left, the car goes left. A stack is the same way. We define it by what it does, which is enforcing that LIFO rule, not by the specific code that makes it tick. Now, to make sure that LIFO rule is never broken, a stack has a very small, very specific set of tools. You can't just reach into the middle of the pile and grab whatever you want. Nope. You have to use the official toolkit. Let's meet the two big ones. First up is push. It's exactly what it sounds like. When you want to add something new to your stack, you push it right on top. Simple as that. It's just like putting that new clean plate onto the pile. And its partner in crime is POP. When you need to get an item back, you pop it off the top. And here's the key part. You don't get a choice. You can only take the very last thing that you put on. The newest item is the only one you can access. And really, that's pretty much the whole dashboard. You can push something on, pop something off, and maybe ask a couple of simple questions like, hey, is there anything in there? Or how many items do we have? That's it. This super limited, simple set of controls is exactly what makes the stack so predictable and so powerful. Okay, theory is cool and all, but let's see where this simple little tool can do something that feels, well, honestly, a little bit like magic. We're going to look at a strange puzzle. How in the world do computers understand math without needing parentheses? So on the left, you see how we write math, 1 plus 2. But computers, they often prefer what's on the right, 1, 2 plus. It looks weird, I know. It's called postfix notation. The operator comes after the numbers. The reason they love this is that it's super clear. There's no confusion about the order of operations. The puzzle for us is, how does a machine read 1, 2 plus and know the answer is 3? Yep, you probably guessed it. The stack is the perfect tool for this job. That strict last in, first out rule is exactly what we need to crack this postfix puzzle. So let's just walk through it one piece at a time. The method is beautifully simple. It's just two rules. As we read the expression from left to right, we do one of two things. If we see a number, we just push it onto our stack. If we see an operator, like a plus or minus sign, we pop two numbers off, do the math, and then push the answer back onto the stack. Or let's trace our expression, 1, 2 plus. The very first thing we see is the number 1. Rule number 1 says if it's a number, push it onto the stack. So boom. Our stack now just has the number 1 in it. Next up is the number 2. Same rule applies. It's a number, so we push it onto the stack. Our stack now has a 1 with a 2 sitting right on top of it. And now for the fun part. We hit the plus sign. That's an operator, so it's time for rule 2. We pop two numbers off the stack. Because of LIFO, the 2 comes off first, then the 1 comes off. For a split second, our stack is completely empty. But only for a second, because we immediately take those two numbers we just popped, 1 and 2, and we do the math. 1 plus 2 gives us 3. The final part of the rule says to push that result back onto the stack. So now our stack just has one number in it, 3. And because we've reached the end of the expression, the algorithm is done. The final answer is whatever is left on the stack. And look at that, it's 3. See? The stack let us hold on to those numbers in just the right order until we were ready for them. Pretty cool, right? So this abstract idea, it sounds great, but what does it actually look like in code? You might be shocked at how simple it is. Let's take a peek at how you could do this with a basic Python list. Remember our push operation for adding things? Well, in Python, it's just the list's append method. When you append to a list, it adds the new item to the very end, which is a perfect way to mimic putting a new item on top of the stack. It's literally that easy. And what about pop? Well, Python lists have a method that is literally called pop. And what it does is remove and give you back the very last item. It's a perfect one-to-one match. That big abstract concept we talked about is implemented with a single familiar line of code.
Okay, so now that you get the what, the why, and the how, I guarantee you're gonna start seeing stacks everywhere. This isn't just for some weird math notation, it's a pattern for solving an entire class of problems.
Think about it. That undo function in a text editor, every single thing you do gets pushed onto a stack of actions. When you hit undo, the last action is popped off and reversed. It's the same for your browser's back button. Every page you visit gets pushed onto a history stack. It's also the secret to solving tons of common programming puzzles you might run into. So the most important thing to take away here is that a stack isn't just a piece of code. It's a mental model. It's a way of thinking. So my question for you is this. Now that you know the last in, first out rule, what other problems in your daily life or things you see online are actually just stacks in disguise?